Students, continue the problems. So today can discuss one of the matrix of 3 cross 3 matrix to find the inverse of the matrix by using elementary operation. In yesterday we can discuss some 2 cross 2 matrix. But 3 cross 3 matrix is not necessary for the examination purpose. Just we'll revise one of the problems. Only 2 cross 2 matrix can be given as in an examination 3-mark question. But 3 cross 3 is not necessary, but once we'll observe that. Now, by using elementary row operation, I is equal to A is equal to I into A, where A is nothing but 1, 3, minus 2, minus 3, 0, minus 5, 2, 5, 0, and identity is nothing but 1 0 0 0 1 0 0 0 1. It's also considered in the 3 cross 3 matrix into A. Now, if it is reduced in the form of I is equal to B into A, means left hand side of the matrix can be reduced into their identity matrix. Automatically right hand side is changes with the some another matrix. Such a matrix is called as inverse of A. Now, first condition is, first elements of identity is nothing but 1, but if it is already exist. So, then the next two elements are will be considered for these two, second row and then third row. Therefore, R2 can be changes with, both are will be operated in one of the equation. R2 can be changes with R2 minus, and if it is depends on the corresponding elements of the first row. So, minus 3 plus 1. If these two are directly get adding or subtracting with each other, if not, it's not equal to 0. Suppose, if all the elements of the first row are multiplied by 3, minus 3 plus 3 is nothing but 0. Therefore, if their elements of R1 are multiplied by 3 and these elements are adding with the corresponding elements of R2. Therefore, R2 can be changes with R2 plus 3 times of R1. So, similarly, R3 is also operated in the same steps. Now, R3 is also depends on their R1. Again, these two elements are comparing with each other, but these two are not equal. So, therefore, if all the elements of the first row are it's multiplied by 2 and subtracting with the corresponding elements of R3. But ಇಲ್ಲಿ ಎರಡು ಪಾಸಿಟಿವ್ ನಲ್ಲಿ ಇರೋದ್ರಿಂದ both are will be positive, therefore get subtraction of these two condition. But in second row, one of them is positive and another one is negative, get adding with each other. Therefore, R3 changes with R3 minus 2 times of R1. R3 minus 2 times of R1. Therefore, the first rows are 1, 3, minus 2, and in their RHS is also 1, 0, 0 into A. Then their calculation, second row, R2 can be changes with R2 plus 3 times of R1, where R2 is minus 3 plus 3 times of corresponding R1 is 1. So, minus 3 plus 3 is 0. That is the first element. Similarly, second element, R2 is 0 plus 3 times of corresponding R1. So, 0 the corresponding R1 is to the 3. So, these two are get simplified. 3 into 3 is 9. Similarly, third element, R2 is minus 5 plus 3 times of corresponding R1 is minus 2. So, get simplified. Minus 5 minus 3 into 2 is 6. Minus 5 minus 6 is minus 11. Similarly, in the right hand side, R2 is 0 plus 3 times of corresponding R1. Corresponding R1 is 1. So, it will be equal to 3. Similarly, R2 is 1 plus 3 times of their corresponding R1 is 0. So, 1 plus 3 into 0 is 1. Last element, R2 is 0 plus 3 times of corresponding R1 is also 0. that is nothing but 0. Similarly, the third condition, R3 can be changes with R3 minus 2 times of R1. R3 minus 2 times of R1. So R3 is 2 minus 2 times of corresponding R1. Corresponding R1 is 1. That is 2 minus 2 is equal to 0. Similarly, next element of R3, 5 minus 2 times of corresponding R1 is 3. So 5 minus 6 is minus 1. Then last element, R3 is 0 minus 2 times of corresponding R1 is minus 2. That is minus into minus is plus 4. And in RHS, R3 is 0 minus 2 times of corresponding R1 is 1. That will be equal to minus 2. Second element, R3 is 0 minus 2 times of corresponding R1 is also 0. That is 0 minus 0 is 0. The last element, R3 is 1 minus 2 times of corresponding elements of R1 is 0. 1 minus 2 into 0 is 0. So therefore, once we'll operating R2 and R3, elements of left hand side are in the form of 1 3 minus 2, 0 9 minus 11, 0 minus 1 4. So after that, then we'll come to the next condition is diagonals. What are the diagonal elements of the identity matrix will be concentrated. So if these elements is nothing but 1, therefore R2 can be changes with R2 divided by 9. So now we'll 1 ಮಾಡಬೇಕಿರುತ್ತೆ. So that division process, therefore 9 ಇರೋದ್ರಿಂದ equation whole elements of R2 are get dividing throughout by 9. So that is first elements are does not altered. In both of the side, first rows are will be written as in the same form. And last row, 0 minus 1 4 minus 2 0 1. It's also will be continuing in the same elements. But second row can be changes with second row divided by 9. Means what are the elements of the second row are get dividing by 9. 0 divided by 9 is 0. 9 divided by 9 is 1. Minus 11 divided by 9. Similarly, in RHS, 3 divided by 9. 3 by 9 is nothing but 1 by 3. So 1 divided by 9 and 0 by 9 is 0. So next we'll consider upper and lower elements of corresponding 1. Identity elements ಅಲ್ಲಿ 1 ಬಂದಾದ್ಮೇಲೆ ಅದ್ರದ್ದು upper elements and lower element ನ concentrate ಮಾಡಿ. Now R1 changes with, but if it is depends on R2, R1 changes with R1 minus 3 times of R2. Suppose if these two elements are either adding or subtracting with each other, if it is not equal to 0, therefore these elements can be operated by using the condition of, in the terms of R2 are multiplied by 3 and these elements are subtracting with the corresponding elements of R2. So therefore R1 can be changes with R1 minus 3 times of R2. Similarly, R3 can be changes. Now it's also depends on R2. R3 is also depends on R2. Once we'll check whether, suppose if these two are get adding or subtracting with each other, is 0 or not? Yes, it will be 0 after additions of these two elements. Minus 1 plus 1 is nothing but 0. Therefore R3 can be changes with R3 plus R2. Directly get adding with each other. Get continuing. First and third row can be operated. Therefore, in the second row elements are does not changes. 0, 1 minus 11 divided by 9. Similarly, in their RHS, 1 by 3, 1 by 9, 0. R will be continuing in the same form. Now will be operating first and third row. Therefore, the elements of the second row are does not alter. Get operating first row. R1 changes with R1 minus 3 times of R2. R1 minus 3 times of R2. R1 is 1 minus 3 times of corresponding R2 is 0. That is 1 minus 3 into 0 is 1. Similarly, R1 is 3 minus 3 times of corresponding R2 is 1. That is 3 minus 3 is 0. Now, third element, R1 is minus 2 minus 3 times of corresponding R2 is minus 11 divided by 9. Get simplified. Minus 2 minus into minus is plus 3 ones are 3 3s are 11 divided by 3. So get an LCM. 3 is an LCM. Minus 6 plus 11 is 5 divided by 3. 5 divided by 3. Similarly, in RHS, R1 is 1 minus 3 times of corresponding R2 is 1 by 3. These 3 are get cancelled. 1 minus 1 is 0. The second element, R1 is 0 minus 3 times of corresponding R2 is 1 by 9. So 3 ones are 3 3s are 9 is get cancelled. It will be equal to minus 1 by 3. Again, last element, R1 is 0 minus 3 times of corresponding R2 is also 0. That is 0 minus 0 is 0. These are the elements of the first row. So similarly, can be operate in the third row. So third row, R3 can be changes with R3 plus R2. R3 plus R2. Now R3 is 0. Corresponding R2 is also 0. 0 plus 0 is 0. Again, second element R3 is minus 1 plus corresponding R2 is plus 1. Plus 1 minus 1 is 0. The last element R3 is 4 plus corresponding elements of R2 is minus 11 divided by 9. So LCM. So 9 is an LCM. 9 into 4. Plus into minus is minus 11. So 36 minus 11 is 25 divided by 9. 25 divided by 9. Then second RHS. R3 is minus 2 plus R2 is 1 by 3. Again LCM. 3 minus 6 plus 1, it's minus 5 divided by 3. Second element, R3 is 0 plus corresponding R2 is 1 by 9. 0 plus 1 by 9 is 1 by 9. So last one, R3 is 1 plus corresponding R2 is 0. That is 1 plus 0 is 1. So these are the elements of R3 operation on elementary transformation. Then next we'll consider the third element is 25 divided by 9. So according to their identity element, if it is again nothing but 1. Therefore R3 can be changes with R3 divided by 25 by 9. Otherwise it's also can be written as 9 by 25 of R3. Means what are the elements of R3 are get dividing by 25 by 9. Otherwise it's multiply by 9 by 25. Therefore the elements of first and second rows are does not altered in both LHS and then RHS. But in the third row can be operated. R3 changes 9 by 25 of R3. So 0 into 9 by 25 is 0. And the second element is also 0 into 9 by 25 is 0. 25 by 9 into 9 by 25 is nothing but 1. Similarly, in their RHS, minus 5 divided by 3. R3 is minus 5 divided by 3 into 9 divided by 25. Get simplified. 5 ones are 5 5s are 3 ones are 3 3s are. That is plus into minus is minus 3 divided by 5. Similarly, second element. R3 is 1 by 9 into 9 divided by 25. After that 9 get cancelled, 1 divided by 25. And the last element 1 into 9 by 25 can be written as 9 divided by 25. These are the elements of R3. So next we'll operate second and then third row. Means what are the elements of the diagonal is 1. Identity prakara diagonal elements 1 bandadmele upper of these two diagonals are nothing but 0. Adige iveradana 0 madlikke can be operate R1 and R3. So 0 ಮಾಡಬೇಕು ಅಂದರೆ corresponding elements are get multiplied by R3. Therefore R1 can be changes with R1 minus 5 divided by 3 times of R3. So R1 minus 5 by 3. It means 5 by 3 is multiplied by in all the elements of R3 and subtracting with the corresponding elements of R1. Similarly, R3 can be changes. R2 can be changes with R2 plus. Already negative is it's become adding. R2 plus 11 divided by 9 of R3. R2 plus 11 divided by 9 of R3. Therefore, the third row I will be continue in the same elements on both LHS and then RHS. Third rows are 0, 0, 1 and in the right hand side is minus 5 divided by 3 divided by 5, 1 divided by 25 and 9 divided by 25. So then we'll get operate in first and then second row. So in first row is nothing but R1 minus 5 divided by 3 times of R3, where R1 is 1 minus 5 by 3 of corresponding R3 is 0. That is again nothing but 1. Similarly, second element R1 is 0. R1 is 0 minus 5 by 3 of corresponding R3 is also 0. 0 minus 0 is 0. And the third element R1 is 5 divided by 3 minus 5 by 3 of corresponding R3 is 1. That is 5 by 3 minus 5 by 3 is 0. Similarly, in RHS, R1 is 0 minus 5 by 3 of R3. 0 minus 5 by 3 of R3 is nothing but minus 3 by 5. So after simplifying these two, minus into minus is plus 1. Then next element R1 is minus 1 by 3 minus 5 by 3 into corresponding R3 is 1 divided by 25. Get simplify. Minus 1 by 3, 5 ones are 5 5s are 25s get cancelled. 3 into 5 is minus 1 divided by 15. LCM 15 is an LCM. Minus 5 minus 1, that is minus 6 divided by 15. Minus 6 divided by 15. Otherwise it's also can be written as minus 2 divided by 5. 3 in the divide ಮಾಡಿ minus 2 divided by 5. Similarly, the next element is R1 is 0 minus 5 divided by 3 of corresponding R3 is 9 divided by 25. So get simplify. 3 ones are 3 3s are 5 ones are 5 5s are minus 3 divided by 5. Minus 3 divided by 5. So then we'll come to the second row. Now second row can be operate, R2 can be changes with R2 plus 11 divided by 9 of R3. R2 plus 11 divided by 9 of R3. Now first elements of R2 is 0 plus 11 by 9 of R3 is also 0. That is 0 plus 0 is nothing but 0. Second element R2 is 1 plus 11 divided by 9 of corresponding R3 is 0. That is 1 plus 11 by 9 into 0 is 1. Third element R2 is minus 11 divided by 9 plus 11 by 9 of corresponding R3 is 1. That is 0. Similarly, in RHS, R2 is 1 divided by 3 plus 11 divided by 9 of corresponding R3 is minus 3 divided by 5. So 1 by 3, 3 ones are 3 threes are plus into minus is minus 11 divided by 15. LCM is 15, 5 minus 11. So 5 minus 11 is minus 6 divided by 15, otherwise minus 2 divided by 5. Minus 2 divided by 5. Then second element R2 is 1 by 9 plus 11 divided by 9 of corresponding R3 is 1 divided by 25. So 1 by 9 as a common factor, 1 plus 1 by 25, LCM is 26 divided by 25 into 9. 26 divided by 225. Then third element. So R2 is 0 plus 11 divided by 9 of R1 is 9 divided by 25. Again 9 get cancelled. 11 divided by 25. 11 divided by 25. Therefore, if it is in the form of I is equal to B into A, therefore that B is called the inverse of A. Therefore, A inverse is equal to 1 minus 2 by 5 minus 3 by 5 minus 2 by 5, 26 divided by 225, 11 divided by 25 minus 3 divided by 5, 1 divided by 25 and 9 divided by 25. So that is the inverse of the given matrix A. And if these problems are not necessary for the purpose of annual examination, just will observe once will. So next one is some miscellaneous examples. But ಇವಾಗಿನ ಕ್ಲಾಸಸ್ ಅಲ್ಲಿ some problems ಮಾತ್ರ ಮಾಡಿಸ್ತೀನಿ, ರಿಮೈನಿಂಗ್ ನಾವು ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸಸ್ ಅಲ್ಲಿ ಡಿಸ್ಕಷನ್ ಮಾಡ್ಬೋದು. So let A equals 2 minus 1 3 4, B equals 5 2 7 4, C equals 2 5 3 8. If all these three are some 2 cross 2 matrices, find the matrix D. It's another one of the matrix D such that CD minus AB is equal to 0. Means by using that equation to find the elements of some matrix D, but it's also a one of the 2 cross 2 matrix. But how will be called as 2 cross 2 matrix? D na ನಾವು 2 cross 2 ಅಂತ ಹೇಗೆ ಕರಿಬೋದು ಅಂದರೆ, after either addition or subtractions of 2 matrices are having the same order. ಸೊ ನೀವು ಆ್ಯಡ್ ಮಾಡಬೇಕು ಅಂದರೆ, ಸಬ್ಟ್ರಾಕ್ಷನ್ ಮಾಡಬೇಕಂದ್ರೆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಸೇಮ್ ಆರ್ಡರಲ್ಲಿ ಇರಬೇಕು. ಇಲ್ಲಿ ಆಲ್ಜಿಬ್ರಾಯಿಕಲಿ ಸಬ್ಟ್ರಾಕ್ಷನ್ ಆಫ್ 2 matrices ಇರೋದ್ರಿಂದ D is also a 2 cross 2 matrix. Now first we'll consider elements of D are in the general form. These elements can be represented in either A, B, C, D or X, Y, Z. ಯಾವುದ್ರಲ್ಲಿ ಬೇಕಾದ್ರೂ ಯೂಸ್ ಮಾಡಿ. But if these elements can be written as in the form of small letters, either in A, B, C, D or X, Y, Z, X, Y, Z, W can be represented in the small letter. These are the elements of D. Now to find the values of A, B, C, D by using that equation, these are the elements of the matrix D. Now we will be consider the equation CD minus AB is equal to 0, but it's also can be written as CD is equal to AB. CD is equal to AB. Get substitute the elements of C and D. C is 2, 5, 3, 8. Into D is A, B, C, D equals A is 2 minus 1, 3, 4. Into B is 5, 2, 7, 4. We'll observe that both LHS and RHS is a product of two matrices. Therefore, first we'll get multiply these two matrices by using the condition of row with column operation. In first row, first column, 2 into A is 2A plus 5 into C is 5C. These are the elements of the first row, first column. Similarly, elements of first row, second column, 2 into B is 2B plus 5 into A is 5A. These are the elements of the first row, second column. Similarly, in the second row, first column, 3 into A is 3A plus 8 into C is 8C. Then last one, second row, second column, 3 into B is 3B plus 8 into D is 8D. It will be equal to. Similarly, in the right hand sides are also multiplied with each other, the corresponding elements of rows and columns. 2 into 5 is 10, minus 1 into 7 is minus 7. That is an element of first row, first column. Similarly, first row, second column, 2 into 2 is 4, minus 1 into 4 is 4. Then we'll come to the second row. Second row, first column, 3 into 5 is 15. Plus 4 into 7 is 28. Then second row, last column, 3 into 2 is 6. Plus 4 into 4 is 16. So get simplify. 2A plus 5C, 2B plus 5A, 3A plus 8C, 3B plus 8D. 5D. It will be equal to 10 minus 7 is 3, 4 minus 4 is 0, 15 plus 28, 43, 6 plus 16, 22. So then these two are in the form of equalities of two matrices. Now how to get equalities of two matrices? Corresponding elements are directly equating with each other. Therefore the first elements are 2A plus 5C is equal to 3. That is one of the equation. Similarly, second elements 2B plus 5D is equal to 0 is called as an equation 2. Third one 3A plus 8C is equal to 43 is called as an equation 3. And fourth one is 3B plus 8D is equal to 22. It's called as an equation 4. Now these equations are called as simultaneous equation. Therefore solving these equations by using their corresponding elements. Solving in equation 1 and 3. Solving in equation 1 and 3, 2A plus 5C is equal to 3, 3A plus 8C is equal to 43. In the first equation it's multiplied by 3 and the second equation is multiplied by 2. So 3 into 2 is 6A, 3 into 5 is 15C, 3 into 3 is 9. Again 2 into 3 is 6A, 8 into 2 is 16C equals 43 into 2 is 86. Get subtracting in these two equations, minus, minus, minus. Plus 6a minus 6a are get cancelled. 16c minus 15c is nothing but minus c. Minus 86 plus 9. Minus 86 plus 9 means get subtracting in these two equations. That is nothing more. Minus 87. So these minus minus are get cancelled. Therefore c is equal to 87. 77. So therefore the values of c is equal to 77. Then such a value can be substituted in any one of these two equations. Put c is equal to 77 in equation 1. That is 2 into a plus 5 into c is nothing but 77 is equal to 3. So therefore 2a is equal to 3 minus 77 into 5. 385. So 385 minus 3. Minus 382. So therefore a is equal to minus 382 divided by 2. That is 2 ones are 2 nines are 2 ones. Therefore a is equal to minus 191. These are the values of a. Then similarly subtracting in equation 2 and 4. So now we will already solving in equation 1 and 3. So similarly get solving in equation 2 and 4. So in equation 2 is nothing but solving in equation 2 and 4. So 2 is 2b plus 5d is equal to 0. 3b plus 8d is equal to 22. The first equation is multiplied by 3 and the second equation is multiplied by 2. So 3 into 2 is 6b plus 15d is equal to 0. 6b plus 16d is equal to 44. Again get subtracting in these two equations. Plus 6b minus 6b are get cancelled. 16d minus 15d is nothing but minus d is equal to minus 44. This minus minus are get cancelled. Therefore d is equal to 44. Then substitute the values of d. So d is nothing but 44. Such a value can be substituted in any one of these two equations. Put d is equal to 44 in equation 2. That is 2b plus 5 into d is nothing but 44 is equal to 0. Therefore 2b is equal to 44 into 5 minus 220. Therefore b is equal to minus 220 divided by 2 is nothing but 110. So these are the elements of b. Therefore these elements, a is nothing but minus 191, c is nothing but 77, d is 44 and b is minus 110. Therefore the elements of the matrix D, elements are generally written as a, b, c, d. Therefore the elements are matrix D is minus 191, b is minus 110, c is 77 and d is 44. So these are the elements of the matrix D.